Look, everybody knows the numbers. 100 billion galaxies, each one packed with 100 billion stars, planets everywhere you look. And you sit back and you say, well, obviously, somebody else is out there. It would be crazy to think otherwise. With all those chances, all those rolls of the dice, of course there is someone, probably millions of someones, maybe billions of civilizations scattered across the sky, chatting away, building things, wondering about us the same way we wonder about them. That is the most natural, most reasonable, most intuitive conclusion a human being can draw, and I think it is completely wrong. Not because I want it to be wrong, not because I enjoy making people uncomfortable, although sometimes I do, but because I sat down with a pencil and a piece of paper and actually did the arithmetic. And when you do the arithmetic honestly, when you refuse to let wishful thinking sneak in through the back door, you end up in a very cold, very quiet room, and you are the only one in it. Now, I want to take you through this carefully, because the logic that leads most people to believe in a crowded cosmos sounds airtight at first. It really does. And I want to show you exactly where it develops a crack. And then I want to show you what is hiding inside that crack. Because what is hiding there is not just a scientific puzzle. It is something that should change the way you live your life. Let's find things out together. Start with the galaxy we live in, the Milky Way, roughly 200 billion stars. Now, we know from what astronomers have pieced together over the past few decades that most stars have planets, not a special few. Most of them. The average star has at least one planet going around it, and many have several. So in our galaxy alone, you are already looking at hundreds of billions of planets. Some estimates push higher than that, closer to 1 trillion when you count the small ones. Fine. Of those, a meaningful fraction sit in what the astronomers call the habitable zone. Not too close to the star, not too far. The range where liquid water could sit on the surface without instantly boiling off or freezing solid. Tens of billions of potentially habitable worlds in this one galaxy. And then you multiply that by the number of galaxies in the observable universe, which is itself somewhere around 200 billion, and you end up with a number that is almost meaningless in its size. Something like 10 to the 22nd or 10 to the 23rd potentially habitable planets across the observable universe. That is 10,000 billion, give or take. And people look at that number and they say, case closed. There is no way we are alone. The math simply will not allow it. I understand why they feel that way. I genuinely do. If you told me there were 10,000 billion lottery tickets and only one of them was a winner, I would bet everything I own that someone is holding it. The numbers seem too large for luck. But here is where the trouble starts, and here is where people make the mistake, because having a habitable planet is not the same thing as having life. And having life is not the same thing as having intelligence. And having intelligence is not the same thing as having technology. And having technology is not the same thing as having that technology operating right now at this precise moment in cosmic time when we happen to be pointing a radio telescope at the sky. Each one of those steps is a filter, and we have no idea how fine those filters are. That is the part that gets glossed over. People get excited about the enormous number at the top, and they forget to ask, what do I need to divide it by? And the dividing is where the whole picture changes. There is a famous equation for organizing this problem. Frank Drake wrote it down in 1961. It is not really an equation in the rigorous physics sense. It is more of a structured way of cataloging what you do not know. You start with the rate of star formation in the galaxy. Multiply by the fraction of stars with planets. Multiply by the number of habitable planets per star system. Multiply by the fraction of habitable planets where life actually develops. Multiply by the fraction where life becomes intelligent. Multiply by the fraction that develops communication technology. And then multiply by the average lifetime of such a civilization in years. Beautiful structure, terrible data. Because the first three terms you can estimate reasonably well with modern astronomy. But terms 4 and 5 and 6 and 7, we are guessing. We are completely, thoroughly, honestly guessing. And depending on what you guess, the answer ranges from millions of civilizations in our galaxy right now to something considerably less than one. The equation does not tell you the answer. It tells you what you do not know. And what you do not know turns out to be almost everything that matters. Let me take you through each of those unknowns one at a time, because each one deserves to be looked at honestly rather than optimistically. The first unknown is the step from a sterile planet with the right conditions to actual life. Simple, single-celled life. How hard is that step? Well, we know it happened here. And it seems to have happened reasonably quickly in geological terms. Within a few 100 million years of the Earth cooling down enough to have liquid water, something was alive and doing chemistry. That makes some people think the step is easy. Chemistry plus water plus energy plus time equals life. Simple recipe. But we have one example, one. And that one example is catastrophically biased, because if life had not arisen here, we would not be standing here asking the question. You cannot draw a statistical conclusion from a sample of one when the sample was selected by the very outcome you are studying. That is not science, that is a card trick. For all we know, the origin of life requires such a specific and improbable sequence of chemical accidents that it happens on only one planet out of every 10 to the 20th. If that is true, then even with all those habitable worlds, you would expect life to arise across the observable universe perhaps once, maybe, and we would be it. I am not saying that is the number. I am saying we do not know the number. And people pretend they do because it feels like it should be high because life happened quickly here. But feeling is not calculating. Those are two very different activities, and they produce very different answers. Let me give you an analogy to make this precise. Imagine you are dealt 5 cards, and they are a royal flush. You might say, well, that happened quickly, so it must be easy to get a royal flush. That is obviously wrong. It happened quickly in the sense that it happened in one deal, but the probability of that particular hand is 1 in 649,000. Your sample of 1 tells you nothing about the underlying probability. The origin of life is the same kind of problem. We got the royal flush on the first deal. That does not tell us how hard the deal is. It just tells us we were dealt. Now move to the second filter. From simple life to complex life. From bacteria to something with cells that have a nucleus. From single-celled to multicellular. From simple to complicated. Here, the picture gets even darker. Because even on Earth, even with all the time available, this transition took an extraordinary amount of time. Life appeared on Earth something like 3.5 billion years ago. But for most of that time, for roughly 2 billion years, the most complicated thing on the planet was a single cell with a nucleus. That is it, 2 billion years of nothing much happening. The transition to complex multicellular life was not quick, it was not obvious. It required a specific event, a specific merger between 2 kinds of single-celled organisms that produced the kind of cell that could eventually build eyes and brains and hands. Some biologists think that merger was extraordinarily improbable, that if you ran the tape of life again, you might get bacteria filling the oceans of Earth forever and nothing more. Bacteria are wonderfully successful. They do not need to evolve into anything else. They are already winning. The drive toward complexity is not guaranteed. It is not written into the laws of physics. It happened here, once, and we do not know why. And then, even if you get complex life, you need to get to intelligence. And intelligence is not the obvious destination of evolution. Evolution does not aim at anything. It does not have a goal. It produces whatever survives long enough to reproduce. The dinosaurs were extraordinarily successful for 160 million years. They did not produce a technological civilization. They did not need to. They were doing fine. Intelligence is metabolically expensive. A human brain runs on roughly 20 watts of power, which sounds modest, but it consumes about 20% of our body's total energy while being about 2% of our body's mass. That is a staggering caloric investment. For most of evolutionary history, that investment would not have been worth making. You need a very specific set of conditions to make intelligence advantageous enough for natural selection to push hard in that direction. And even when you get intelligence, you need the particular kind of intelligence that builds tools, that accumulates knowledge across generations, that eventually produces radio telescopes. Most intelligent animals do not do that. Dolphins are intelligent, octopuses are remarkably intelligent, crows solve problems that would challenge young children. None of them are building particle accelerators. The gap between intelligence and civilization is enormous, and we crossed it exactly once. Now add one more filter on top of all of these. Even if a civilization develops and starts broadcasting radio waves or some other signal into the cosmos, it has to survive long enough for that signal to reach us. And this is where the problem becomes almost personal. Because when you look at our own civilization, it is not obvious that we are particularly good at surviving. We have nuclear weapons sitting in silos right now, enough to end organized human life several times over. We are changing the chemistry of our atmosphere in ways we do not fully understand. We have not solved the problem of making rational collective decisions at scale. The history of human civilization is littered with collapsed societies. And we have only been a technological civilization for about 150 years. If that is the typical lifespan of a civilization, if species tend to invent radio and then within a few centuries either destroy themselves or collapse back into something quieter, then even if civilizations have arisen all over the galaxy, almost none of them would be broadcasting at this particular moment. The window of overlap is tiny. Ships passing in the night, except the night is 13 billion years long and the ships are lit for an instant. This brings us to the central puzzle. The paradox that is named after a physicist who raised it at lunch one day in 1950. Enrico Fermi, who was one of the sharpest minds of the 20th century, was having lunch with some colleagues in Los Alamos. They had been joking about flying saucer reports in the newspapers. And then the conversation drifted to more serious territory, to the real question of whether civilizations existed elsewhere in the galaxy. And Fermi did what Fermi always did. He thought carefully and did a quick calculation in his head. And then he asked a very simple question. He said, where is everybody? Because if intelligent civilizations are common in the galaxy, they should be everywhere by now. The galaxy is old. It has been around for over 10 billion years. If even one civilization in that entire history had developed the capacity for interstellar travel and the motivation to use it, they would have colonized the entire galaxy long before the Earth was even formed. The numbers on this are not ambiguous. Even traveling at a tiny fraction of the speed of light, a civilization with the patience to send probes to nearby stars, which would themselves send probes to further stars, could fill the entire Milky Way within a few million years. A million years sounds like a long time. It is nothing in a galaxy that is 10 billion years old. If any civilization had done this, even once, we would know. There would be evidence everywhere. There would be artifacts, structures, signals. The galaxy would not look pristine and untouched. And yet it does. It looks exactly as if nobody has ever been here. Where is everybody? The answers people give to that question are called the solutions to the Fermi paradox, and there are many of them. Let me walk you through the main ones, because they are worth understanding, and because most of them, when you look at them carefully, are less reassuring than they first appear. The first category of answer is what you might call, they are there, but we cannot see them. Maybe civilizations exist, but do not broadcast. Maybe advanced civilizations go quiet, move to more efficient communication technologies, fiber optics of some kind, rather than wasteful radio waves leaking into space. Maybe they are deliberately silent, hiding. Maybe they are watching us, observing, waiting for us to reach some threshold before making contact. These are the zoo hypothesis, the dark forest hypothesis, the interstellar silence hypothesis. They all have one thing in common. They are unfalsifiable. A theory that explains everything explains nothing. If your model of alien intelligence has been adjusted 17 times to account for 17 failures of detection, and each adjustment involves the aliens doing something we cannot possibly detect, then you have not built a scientific hypothesis. You have built a theology. The absence of evidence becomes evidence of nothing. You can always add another layer of hiding. The second category is they have not gotten here yet. The galaxy is big. Interstellar travel is hard. Even for a spacefaring civilization, the distances are so enormous that filling the galaxy could take longer than we think. Maybe nobody has made it to our solar system yet. Maybe we are just early. But this runs into the arithmetic problem. 10 billion years is a very long time. Even optimistic estimates for the slowness of interstellar colonization give you tens of millions of years at most. And 10 million years is still only 1/10 of 1% of the age of the galaxy. The mathematics of the colonization timeline is really not kind to the "we are just early" hypothesis. The third category is the most unsettling, and it is the one I find myself coming back to when I think honestly about this problem. Maybe the filters are behind us. Maybe the reason we do not see other civilizations is that the steps required to produce a civilization are so improbable that they almost never happen. That means those filters are in our past. That the origin of life was a near miracle. That the development of complex life was a near miracle. That the evolution of intelligence was a near miracle. That the development of civilization was a near miracle. And we happen to win all those lottery tickets in a row. In that case, we are not early, we are not late. We are simply extraordinarily, almost impossibly rare. And because we are rare, the universe is mostly empty, mostly silent. And the silence is not a temporary condition waiting to be broken by the first contact with our neighbors. The silence is the answer. But there is a fourth possibility that people sometimes propose, and it is the most uncomfortable one to sit with. Maybe there is a filter ahead of us. Maybe civilizations do arise elsewhere in the galaxy, and they develop technology, and they start broadcasting, and they even begin to look outward, and then something happens, something kills them. Not a meteor, not necessarily, something internal, something that technological civilizations reliably do to themselves. Maybe the development of certain technologies, certain weapons, certain capabilities for self-destruction is a universal feature of the path to intelligence, and maybe it kills you before you can spread. If that is true, then the silence of the cosmos is a warning, a message from every civilization that came before us, sent not in radio waves but in absence. They are not there because they did not make it. And the question is whether we will. I want to be careful here not to be melodramatic. I am a physicist. I work with evidence. And the evidence for a great filter in our future is not strong. It is a possibility, not a certainty. But the evidence for a filter somewhere in the chain, either behind us or ahead of us, is simply the silence itself. We have been listening to the sky for decades now. SETI, the Search for Extraterrestrial Intelligence, has been running serious programs since the 1960s. We have examined thousands of star systems at a wide range of frequencies. We have built better and better instruments. And every single time, the answer is silence. Not a hint, not an anomaly that requires an intelligent explanation, nothing. Zip. Complete and total quiet from the cosmos. Now, you might say we have not been searching long enough. We have only covered a small fraction of the sky at a small fraction of the possible frequencies. That is true. And I do not want to overstate what the silence proves. We could be missing something. The signal could be on a channel we have not thought to look at. But there is a point at which accumulating silence starts to carry its own weight as data. If I search every drawer in your house looking for a specific book and do not find it, at some point I am entitled to conclude the book is probably not in your house. I have not searched every cubic millimeter, but I have searched enough to develop a reasonable conclusion. We are approaching that point with the search for extraterrestrial intelligence, even if we have not yet arrived. What strikes me most about this whole situation is not the science. The science is fascinating and difficult and genuinely unsolved. What strikes me is the philosophical consequence that follows if the pessimistic answer turns out to be right. If we are alone, or nearly alone, or one of perhaps a handful of civilizations in the entire observable universe, then everything changes about the meaning of what happens on this planet. Think about what we have accomplished in a few thousand years. We went from scratching marks on clay tablets to understanding the structure of the atom. We worked out the laws of motion. We decoded electromagnetism. We figured out quantum mechanics, which tells us that the universe at its most fundamental level is nothing like what our intuitions suggest. We figured out that the stars are other suns, that the galaxy is a vast collection of stars, that there are other galaxies, 200 billion of them, that the universe is expanding, that it had a beginning, that it is 13.8 billion years old. And we figured all of this out in a blink. We are talking about 10,000 years of recorded civilization, which in cosmic terms is not even a rounding error. A species of primates on a small rocky planet around an ordinary star in an unremarkable corner of an average galaxy worked all of this out, using nothing but their brains and some clever instruments. That is either the most ordinary thing in the universe or the most extraordinary, and every piece of evidence we have points toward extraordinary. If we are truly alone, or nearly alone, then the universe has been running its experiment for 13 billion years and produced exactly one species capable of understanding it. One in 10 to the 22nd planets. That is a number so small, so close to zero, that it should take your breath away. And if that is the situation, then what happens here matters in a way that does not apply anywhere else in the cosmos. There is no backup civilization. There is no other species going to look up at the sky and ask the questions we are asking. If we figure out how the universe works, that is the universe figuring out how it works, and there is no other channel that process is running on, we are it. And I find that both magnificent and terrifying. Magnificent because it means this thing we are doing, this science, this inquiry, this desperate attempt to understand the laws of nature is not one of many parallel efforts happening across the galaxy. It may be the only effort, the only place in the universe where matter has organized itself well enough to turn around and study the rules it operates by. That is staggering. And terrifying, because if we wreck this, if we burn this planet or blow each other up or simply let ourselves sink into ignorance and tribalism and neglect, there is no second draft. There is no other civilization down the road going to pick up where we left off. The experiment of intelligence in the cosmos may have run exactly once. And the result of that experiment depends entirely on what we choose to do next. I have always believed that the purpose of physics, the purpose of science broadly, is to find out what is true, whether we like it or not. And sometimes what is true is uncomfortable. Quantum mechanics is profoundly uncomfortable to our intuitions. The implications of entropy, that the universe is inexorably moving toward a state of maximum disorder, toward heat death, toward a cold, silent uniformity where nothing interesting ever happens again, that is uncomfortable. The expanding universe is uncomfortable. The finitude of our future is uncomfortable. The nature of consciousness is deeply uncomfortable. And now, potentially, our cosmic loneliness is uncomfortable. But I have never found comfort to be a reliable guide to reality. Nature does not care about your comfort. Nature cares about the rules. There is a famous calculation that gets at this from another angle. The physicist Brandon Carter worked on what is called the anthropic principle in the early 1970s. And one of its consequences, developed further by various people since, is the doomsday argument. The argument goes roughly like this. If you are a randomly selected member of the entire population of humans who will ever live, and you have no idea where in that list you fall, then you should expect to be somewhere in the middle. Not at the very beginning of a vast civilization stretching across millions of years, not the first member of a species that will eventually number in the trillions, just somewhere in the middle. Now look at where we actually are in the history of our species. About 100 billion humans have ever lived. You are among them. If the human population stays roughly where it is and civilizations persist for millions of years, you would be extraordinarily early, far earlier than a random selection from the full list would suggest. Which means, if the argument holds, either civilizations are rare, or they do not typically last very long, or both. It is not a proof. No argument from statistics and probability is a proof. But it is an uncomfortable consistency check. The numbers keep pointing the same way. Let me be absolutely clear about one thing. I am not arguing that we should stop searching. The search for extraterrestrial intelligence is worth doing, precisely because the stakes are so enormous. If we found even one signal, even one artifact, even one anomaly that could only be explained by an intelligent source somewhere out there, it would transform everything we think we know about biology and physics and our place in the cosmos. The absence of evidence is not the evidence of absence. We have not come close to covering the full space of possibilities. There could be signals on frequencies we have not checked. There could be forms of intelligence that operate on timescales or in ways that make them effectively invisible to our current methods. I accept all of that. Keep searching. Search harder. Build better instruments. Look in more places. But I also think we need to be honest about what we have found so far, which is nothing. Decades of searching. Thousands of star systems examined. Every candidate signal turned out to have a natural explanation or to be human-made interference. Nothing that requires intelligence. And a universe that is genuinely teeming with technological civilizations, a universe full of loud, active, broadcasting, expanding species would be very hard to hide from our instruments at this point. We would have found something. At some point, you have to let the absence of evidence accumulate into something. Here is the deep point. The question of whether we are alone is not just a scientific question. It is a question about value and meaning and obligation. If the universe is full of intelligence, then our particular story is one of many. We are a character in a crowded novel. Our choices matter to us, and maybe to our neighbors, but there is a context, a background of cosmic activity against which we are just one thread. If we vanish, others carry on. But if we are alone, if this genuinely is the only place in the visible universe where something looks at the sky and wonders, then the stakes of our choices are not local. They are everything. Literally everything. Every question that will ever be asked, every discovery that will ever be made, every piece of beauty that will ever be perceived. It all runs through this one fragile experiment on this one small planet. And that changes the moral weight of everything we do. You know, I have spent a lot of time studying the laws of nature, and the more I learn, the more astonished I become that anything exists at all, that there is something rather than nothing, that the something is structured by elegant and comprehensible laws rather than by chaos, and that on at least one small world, the matter organized by those laws has produced something capable of understanding them. The universe did not have to produce us. There is no equation in physics that says matter must eventually become conscious and curious. It happened here, once, as far as we can tell. And that, as far as we can tell, is not a minor caveat. That is the whole weight of the argument. So this is Feynman's warning, if you want to call it that. Not that the aliens are coming, not that we should be frightened of what lurks in the dark between the stars. The physics says there is probably nothing lurking there. Nothing with intentions, anyway. The warning is that we are unspeakably rare, and we are behaving as though we are ordinary. As though there will always be another chance, another century, another civilization waiting in the wings to take our place and continue the project of understanding. The physics says otherwise. The physics says the project is ours and it can end. Civilizations are fragile, planets are fragile. The window during which a species is capable of space travel and radio astronomy and quantum physics and all the rest is narrow. It has to stay open deliberately. It does not stay open by accident. The universe is very large and very old and very, very silent. And the most honest explanation I can give for that silence, the one that fits the evidence without requiring me to add 17 layers of hiding and transcendence and unfalsifiable assumptions, the most honest explanation is the straightforward one. Nobody else is talking. We are it. The whole show. The only audience and the only performers. An audience of atoms watching themselves. A universe that has arranged itself in one extraordinary pocket into something that wonders about the rest of the arrangement. What are you going to do about that? See you next time.